So let's go to the third concept, which is inverse. Inverse. Now let's recall this fact. We have talked about the fact that E is the identity element. The identity element. We stated that if we operate on the identity element, you will get the same value. If you operate any number on an identity element, you will get that element back. We also state that in order to know if an operation has an identity, then the operation must be commutative, which means that P operation E should be equal to E operation P, where E is the identity element. Let's also recall that for addition, identity element E is is 0. The identity element for addition is 0. The identity element for multiplication is 1. Now let's go to this concept, inverse. Inverse. If I have 2 plus a certain element, my answer should be the identity element. If I have 2 plus an element here, a certain number, a certain value, my answer should be E, the identity element. Let's remember the identity element for addition is 0. So 2 plus a certain value should give me 0. What is that? What number or what value is that? How can I get 0? What number will I add? What real number will I add to 2 to give me 0? If we are thinking right, then we are talking about negative 2, which then becomes 2 minus 2 equals 0. So the identity element for 2, the inverse of the value 2 is negative 2. Is negative 2 for addition. For addition. Now let's try multiplication. I have 2 times a certain value should give me the identity element. And if you remember correctly, the identity element for multiplication is 1. So if I have 2, then what value will produce the answer 1? And again, if we are thinking correctly, we have half. So half of 2 is 1, or 2 times half. 2 times half is 1. There is it. 2 times half. Now the 2 multiply the 1 up here, so we get 2 on 2. 2 divided by 2 is 1. Okay, so that is what we are talking about as identity. So let's go back to binary operation. If I have a value, an element A, and I operate it by its inverse, please see how we write the inverse. This is how we write the inverse. Then the answer, or this operation, should produce the identity element. That's the definition. If you operate a value by its inverse, the answer should be the identity element. The answer should be the identity element. So let's try example 1.17. Example 1.17. It reads, a binary operation is defined on the set R, or real numbers, by excuse me please, excuse me. Sorry. So that is exactly what I was reading. Example 1.17. A binary operation is defined on the set R of real numbers by P operation Q is equal to P plus Q minus PQ. Now remember, to prove identity, we have to check for commutative. We have to check if the operation is commutative. So we have worked this already. Okay, we have worked this example already, and I'm only going to go through once so that we get better understanding. So for commutativity, we have P operation Q equals Q operation P. Let's do the expansion. P plus Q minus P Q is equal to Q plus P minus QP. Now we have to rearrange alphabetically. P plus Q is equal to P Q equals P plus Q commutativity. Okay, we can change them. NSP Q. Good. So we are proving that the operation is commutative. Now, so we will locate we want to identify the identity element. How do we get identity element? We have done that also already, but let's go on and redo it again. So we are picking one of the elements here. So identity, we have P operation E equals P. Now let's expand. We have P plus E minus EP. Okay, commutative, I can change the two, equals P. We factorize E minus EP here. We have P plus E into brackets 1 minus P, which is equal to P. If we are grouping like terms, then we take P from here, 1 P from here, we take another P from here. So what we left is E 1 minus P equals 0. Because P minus P will be 0, P minus P will be 0. Now if we divide both sides by 1 minus P, we have E equals 0. Okay, so now we are to find the inverse under the operation. We are to find the inverse under the operation. Now let's come back. Let's pick P again. We can pick Q, doesn't matter, but let's use P because that's what we started with. So we are saying that if an element operates on its inverse, the answer is the identity element. So we have P. So inverse, we have P operation its inverse should give us the identity element. Now we have a definition for this operation, which is P plus, so the first element plus the second element minus the product of the first element and the second element. And the answer is E, is equal to E. And we already found E to be 0, So we can simplify, factorize the inverse, P inverse out. So we have P plus, see we have 1 P inverse, another one here. So you can bring the P inverse out. So how many do we have here? We had 1. So 1 P inverse minus, if we take the P inverse from here, what we left here is P is equal to 0. Now we want to take P. You see, we are looking for the inverse. We are looking for P inverse. So we have to move this P from here and the 1 minus P also from here, so that we get only P inverse. at one side of the equation. So if I take away P, so P minus P, okay, plus P inverse 1 minus P equals, because I have taken P out here, I am subtracting by P, and I have to subtract the other side to by P. So the P cancels out the P. That is what you say, take P to the other side. So I'm left with P inverse 1 minus P equals negative P. And what do? I can divide both sides by 1 minus P. So P inverse 1 minus P divided by 1 minus P is equal to negative P divided by 1 minus P inverse. So P inverse, these values cancels out, is equal to my negative P divided by 1 minus P. So the inverse of P is equal to negative P divided by 1 divided by P. Now this is the concept of inverse of an element. Remember, if you operate any element by its inverse, it will produce the identity element. The identity element, we have said that, is only possible if the operation is commutative. So you first have to establish the concept of commutative. Now if you prove that the operation is commutative, then you can prove for the identity element. Now we did for the identity element, we got 0. Good. Then we stated that operation, any element operating on its identity, gives you its inverse gives you the identity element. Since we've already found the identity element to be 0, we will equate the operation to 0. So here we expand and equate to 0. Then we solve for P inverse. Thank you so much, and I hope that you take your time to go through these tutorials. Please note your challenges, note the questions, and you can post them on our page or when we meet in class for further discussion. Thank you.